Okay, so in this module, we're going to look at how to use Redis as a cache. And our use case for this is we want to be able to offer users the ability to see weather at all of our different locations. So they can determine if they want to visit or not based on whether it's going to be sunny or rainy. Now, we don't have a weather gathering service ourselves, so we've sensibly partnered with an external partner who provides us with an API. The use of that API is metered, and above a certain level will start to incur costs. So we want to do something to avoid making requests where we already know the answer or we've recently fetched the weather for a given location. So ideally, we want to cache those responses. Redis makes a great cache because keys can be expired after a certain amount of time. So we can store something in Redis, set an expiry time, and then when we want to get that same thing again, we can check in there, see if it's still there. If it is, great. We'll use the cache version. If it isn't, we'll go out and get it from our Weather API server. So let's take a look at how that looks. Here's a diagram that shows the overall process for both scenarios. So we're going to have a route in our API server. It's going to be /API/location/location ID, so 99 in this case, weather. And what that's going to do is, one way or another, return the weather for that location as a JSON document. So the first thing we're going to do in that route is we'll have a middleware function that checks if we've seen that data recently. So it's going to try and get that data from Redis, and we'll use the key schema ncc:/weather:/location ID for that. If it does receive something back from Redis, fantastic. We've recently accessed this data. We can just return that straight back to the user. And that'll give the user a speed bump because data will be returned a lot faster than making an origin request to an external server. And it saves us time and money on making those requests and racking up our usage of that API. If, however, we haven't seen this weather recently or ever, then we're going to need to do a couple of things. We're going to need to turn that location number 99 into some coordinates. So recall that we stored coordinates for each location in the location's hash. So we can use that hget command and get a single field out of the hash. So we only need the location field. We can then feed that data into the Weather API, make a request across the internet to wherever their servers are, get a response, and then store that response in Redis using the setex command. What that's going to do is both store the response as a string and set an expiry time on it. So we're going to use a number of seconds. We're going to say an hour, which is 3,600 seconds. So let's dive in and see how this works in the code. So I'm here in the routes, location routes file, and let's make some space. We have a route called location ID, weather. What that's going to do is, first off, validate that I passed it an integer and error out if I didn't. And then we're going to have a middleware function that runs next. And its job is going to be to check the cache to see if we received this recently and if we can serve it from Redis rather than make that expensive API call. So we have a function getWeatherKey. That is just a convenience function that is going to turn a location ID into the key ncc:/weather:/location ID. And we're just going to do a simple get from Redis to get the value there. If we receive it, fantastic, we have a cache hit. So we'll log that we have a cache hit and we'll just return the JSON that we received from Redis. So that should be very, very fast and save us a call to the Open Weather API server. If we don't receive anything back from Redis, then unfortunately it's cache miss. We either have never received this data or it's been over an hour since we last used it and Redis deleted it. So what's going to happen here is that we'll just call the next function in the chain. And that function is going to deal only with cache misses. So this one again forms up the locations key. So ncc locations 99, because we need to go and get the location's lat long position. So to get a value from a hash, we use hget. Hget takes a key and potentially many field names, but we only need the one. So we're only going to pull back minimum data we need from Redis. And then once we've got that, we're going to store it in a variable called coords, which is a string. It's going to be longitude, latitude formatted, if you remember from the sample data. So we're going to split it out into two variables, longitude and latitude. Then we're going to make an API call. So OpenWeather's API here responds on this URL. It expects a longitude and a latitude. And it also expects an application ID. So I've stored that in an environment variable. There's instructions in the workbook on how to get your own value for this. And that's how they're going to track us and see how we're using their API. So we're aiming to minimize use of this API with this caching strategy. So assuming that all goes well, we get the JSON response back from the API, and then we're going to store it in Redis. So we're going to use the setex command here. So we're going to store it at, again, get weather key, ncc :weather :location ID. Cache time here is a variable that's set to the number of seconds in an hour. And then we're just going to store a string representation of the JSON document. So that'll be stored in Redis, and we send it back to the user. So that's the cache miss route. So the next time it comes through, we'll get to here and we'll get it out of Redis, and it'll exist in Redis because it's been under an hour, and we'll just send it back, and it should be significantly faster. Let's try it out. So here I'm going to start up my server. I've already set the environment variable weather API key, so that's all right. And I'm going to use Postman for this because it allows us to show the round trip time more easily in a browser. But it's just a simple GET request, so you could do this in the browser. So we're going to go get localhost 8081 application location 99's weather. I'm going to say go get it, and okay, it took 541 milliseconds. We hadn't received this one before, so that was a cache miss. We went out to OpenWeatherMap and actually got the data. And here we can see we went the cache miss route, and we logged that. So what I would expect to happen when I run this again is that 541 milliseconds dramatically reduces for a couple of reasons. Number one, we're not going to make the external call. And number two, Redis is very fast. So we're going to pull the data out of Redis, not make an external call, and return the same document. We get the same document back, and now it took us 13 milliseconds, so substantially faster than the previous one. And as we can see for the log here, we made a cache hit, so we went the other route. So our middleware function intercepted this and returned it, and our origin function that deals with OpenWeatherMap was never called. So what we can do now is take a look here in Insight. I can filter for that key, so it should be ncc weather 99. There it is. When I click on it, you can see that Insight's presented this string as the JSON format that it is. And what's interesting here is I have a time to live, so 3532 seconds left before Redis considers this deleted, and then we go back to the cache miss route. And if I refresh this in Insight, you'll see the cache time is going down. So Redis is tracking that for us. Application doesn't need to do anything at all with that. So in this module, we saw how you can use Redis as a cache. There's several cache strategies. This is a simple one, but it's very effective for saving ourselves time and money on caching things like database calls and API calls. So here we cache an API call, but we could also apply this to if we had a very expensive database lookup that we knew we were going to perform periodically, and if it's a reasonable assumption that a recent call to that would yield approximately the same result as a new call, then it's acceptable to cache it. So in that case, we're saying weather is okay to cache for an hour because within an hour, weather's probably not going to change that much. And the benefits of not calling the API are better than giving the user potentially more up-to-date information. So if you look in the workbook, you'll get to try this out yourself and see what performance gains you get.